Hey there. Today we're going to look at a more complicated stoichiometry problem uh, involving a reaction between nitrogen gas and hydrogen gas to form ammonia. And the question we're going to consider is how many grams of ammonia can be made from a mixture of 100 grams of nitrogen and 5 grams of oxygen. The chemical equation is N2 gas plus 3H2 gas produces 2 NH3 gas. And so here we've got two different substances that are reacting, and we've got different amounts of those substances. And so what we're going to have to think about is when these two gases are reacting together, as they react, one of them is probably going to be used up first, and then we'll end up with leftovers of the other gas. And we don't know to start with which one of these gases is going to be used up first and which one is going to have leftovers. And the way that we're going to figure that out is we're going to think about each of those two reactant gases independently. And so in the case of the nitrogen, we are starting with 100 grams of nitrogen, and we're going to think about how much ammonia could we possibly get from that nitrogen. And the way that we would do this is we would work out the number of moles of nitrogen that we're starting with, and then use the reaction to convert that to moles of ammonia that could be produced, and then finally figure out how many grams of ammonia that is. And then we'll do the same sort of process, focusing on how much ammonia could be produced from the hydrogen. So we've got 5 grams of hydrogen, turn that into moles of hydrogen, moles of ammonia, and finally grams of ammonia. And what we're going to find is that one of those amounts of ammonia is going to be less, and that will tell us which of the two reactants is going to run out first. So the way that we're going to do these calculations is the reaction stoichiometry will give us the relationship between moles of N2 and moles of ammonia, and also the relationship between moles of H2 and moles of ammonia. And then we'll use the molar masses to relate the grams of nitrogen with moles of nitrogen, to relate the grams of hydrogen with moles of hydrogen, and in both cases to relate moles of ammonia with grams of ammonia. So let's go ahead and do this. So we'll work out the molar masses first. So for nitrogen, we've got twice the atomic mass of nitrogen, 14.007 grams per mole. That gives us 28.014 grams per mole for dinitrogen gas. And then for hydrogen, we have twice 1.008 grams per mole, giving a molar mass of 2.016 grams per mole for H2. And then for ammonia, NH3, we have 14.007 grams per mole for N, plus 3 times 1.008 grams per mole for the hydrogens, giving a total of 17.031 grams per mole for the NH3 molecule. Okay, so now we can work out how much ammonia we could imagine getting from each of the two gases individually. So we have enough nitrogen to make a certain amount of ammonia, and we'll find that out by taking 100 grams of N2, converting that into moles by multiplying by 1 mole of N2 per 28.014 grams of N2, so that the grams of nitrogen cancel. And then we will convert from moles of N2 to moles of NH3 using the reaction stoichiometry. There are 2 moles of NH3 produced for every 1 mole of N2 that is consumed. And so here the moles of N2 cancel out. And then finally, to figure out the number of grams of ammonia, we'll multiply by the molar mass of ammonia, 17.031 grams of ammonia per mole of ammonia. Moles of ammonia will cancel, and this will give us grams of ammonia. And putting these numbers into our calculator, we find that there's enough nitrogen to make 121.589 grams of ammonia. And that's not considering how much hydrogen there is. This is just how much ammonia could we get from the nitrogen if all of that nitrogen is able to react, it could produce 121.589 grams of ammonia. And now we'll ask ourselves the same thing for the hydrogen. If all of the hydrogen could react, how much ammonia would it make? Well, we've got 5 grams of hydrogen. Multiply by 1 mole of hydrogen per 2.016 grams. And then multiply by 2 moles of ammonia per 3 moles of H2. That's our reaction stoichiometry. We've got, and then we multiply by 17.031 grams of ammonia per mole of ammonia. We get a bunch of cancellation here and here and here, and we find when we put these numbers into the calculator that if all of the hydrogen could react, it would be enough to produce 28.1597 grams of ammonia. So if all of the nitrogen reacted, we could get about 121 grams of ammonia. If all of the hydrogen reacted, we could only get 28 grams of ammonia. So that tells us that when both of these are reacting together, we're going to run out of hydrogen first, because we're going to run out of hydrogen when we get to the 28.1597 grams of ammonia. And then once we're out of hydrogen, the reaction is going to have to stop. So that tells us that the amount of product that we could get is, in this case, is limited by the amount of hydrogen that we're starting with. And so we can say that hydrogen is the limiting reactant in this case. And then conversely, we've got more than enough nitrogen to react with that hydrogen. And so we can say that there's excess nitrogen gas in this particular example. So the amount of the grams of ammonia that we could make from these starting materials is going to be determined. It's going to be limited by the hydrogen, and we want to round that off to an appropriate precision. And so we would find that under these conditions, we have enough materials to make 28.2 grams of ammonia. So this is the amount of ammonia that we could theoretically make if the reaction, just based on the starting materials that we have in the reaction. And so this number is called our theoretical yield of ammonia. Now, when you actually do a reaction for real, you don't always produce the theoretical yield of product. And the reason is, when you have a set of reactants, we have a reaction in mind that we want to use to produce products, but as the reactants are reacting, you'll get the desired reaction, but then other things will be happening at the same time. So you may have side reactions. The reactants may be able to do other types of chemical reactions, and so that you may end up with a mixture of different products. Another thing that can happen is some of the reactants could get lost. For example, in the case of nitrogen and hydrogen, if some of those gases escape from the reaction container, that would also affect the amount of products that we could get. And usually the most important thing that limits the amount of products is that the reverse reaction occurs at the same time. And so as the reactants are going to produce products, the products can go through the reverse reaction and go back to forming reactants. And so typically what this means is that you'll end up with a mixture of reactants and products. So all of these things mean that when you do a reaction for real, the amount of products that you get is almost never the theoretical yield that you might calculate. Instead, these other processes can happen that will reduce the amount of products that you get. Now, normally when we're trying to do a chemical reaction, we will try to set things up to minimize these side processes and get as much as possible of the desired reaction. But you can almost never completely eliminate these other processes, and so you'll almost never get all of the yield of products that you could theoretically. And so to take an example of this, we just calculated that starting from 100 grams of nitrogen and 5 grams of hydrogen, we could theoretically produce 28.2 grams of ammonia. Now, if we actually did this reaction under normal conditions, if we took 100 grams of nitrogen gas and mixed them with 5 grams of hydrogen gas, we might only get, say, 4.7 grams of ammonia. And so that 4.7 grams would be the actual yield of ammonia. That's the amount that we actually get. And that's just a fraction of what we theoretically expected. And so we could calculate the percent yield for the reaction. What fraction of the theoretical yield did we actually get? And you can see 4.7 grams is a small fraction of the theoretical 28.2 grams yield that we calculated for this reaction. And the exact fraction that it is, well, we would calculate that by just dividing our actual yield, 4.7 grams, by the theoretical yield, 28.2 grams. And then if we multiply by 100%, that will give us our yield as a percent. So we've got 4.7 grams that we actually got from this reaction, divide by the 28.2 grams that we expected, and multiply by 100%, and find that in this case we ended up with only 16.67% of the yield that we theoretically expected. Or rounding off to appropriate precision, our percent yield in this case was 17%. And that may seem like a low number, but that is a typical yield for this particular reaction, reaction between the reaction to form ammonia from nitrogen gas and hydrogen gas is not very efficient, but it does produce ammonia, and it is the process that's used industrially in factories that are making ammonia. So this is how we calculate the yield for a reaction, and that is it for this time around.